Hello, welcome back. Today's question is 130 surrounded regions. We are given a matrix containing X and O's, and our job is to find all the O's that are completely surrounded by X's and flip them to X. So looking at the example provided, you can see the O's here are completely surrounded by X's on all sides, right? So these will be converted to X in the final result. Notice that the O at the bottom here is not surrounded by X. This one, it will not be flipped. Now suppose that instead of an X here, this is an O, then this region will not be flipped because you can see that this area is not completely surrounded by X on all sides. If that is an O, then this entire thing will retain as O's. They will not be X's. Okay, this question is very simple. All we have to do is find the cells that are on the edge and all the neighboring cells connecting to those edge cells. We mark them as some other color, and then we flip all the O's that are not marked, and then we flip all the edge O's regions back to O's. So only 2 iterations. Okay, let's take a look at the code. This C# code is provided in the GitHub links below. First, I will initiate 2 variables, the number of rows and the number of columns on the board. So the number of rows are here and the number of columns are here. And then I'm going to iterate every cells on the board and find all the edge cells. Edge cells are all the cells on the first row, last row, first column, or the last column. For all the edge cells that has a value of O, I'm going to call this recursive function mark cells as Y. This recursive function mark cells as Y first checks whether the input parameters I and J are valid. Being valid means that the I and J values are within the range of the number of columns and the number of rows of the board. Then it will mark the value as Y. After that, it will make a recursive call 4 times for the neighboring cells on the top, on the bottom, on the left, and on the right. These recursive calls will find all the neighbors adjoining the edge cells which have a value of O. And it will also find all the neighbors of neighbors whose has a value of O. Each recursive call will pass in a set of new I and J values. It is possible that some of these I and J values are beyond the border of the board. That is why the isValidCell function is there to check whether that's the case, and if it is so, then it will not execute the call. Once all the edge O cells and all the adjoining neighboring O cells are marked, I would iterate the grid again with a double for loop. I will find all the O's that are not marked in the previous iteration. These will be the cells in the middle, and they're not connected to the edge cells. These I will convert to an X. If I find a Y, that means those cells are connected to an edge cell. I will convert that to an O. And that's all. It's very simple. Let's talk about the runtime complexity. We're only iterating the cells twice. The first time is to find all the edge cells and the connecting cells to the edge cells. And the second time, we are flipping the inner O's to X. And we are flipping also the boards that was labeled as Y's to an O. So the running time complexity is big O of the size of the grid. Okay, let's take a look and see if it works. And it does. See you next time.